1. So they're saying that a particle B of mass 5 kg is at rest on a smooth horizontal table. Then another particle A of mass 2.5 kg moves on the table with a speed of 6 meters per second and collides directly with B. In the collision, the two particles coalesce. Find the speed of the combined particle after collision. So this is directly a question of the conservation of momentum. Since we have two particles, there is no friction since there is a smooth horizontal table. There are two particles and we are to find the speed after collision. So first let's write the formula in terms of this question. Here I have written the formula for the conservation of momentum, where u is the initial velocity and m is the mass, and AB is the combined particle. So first let's write down what we know. The initial speed of A directly before collision is given to us as 6. So this will be 6, and the mass of A was 2.5, and then we have the initial speed of B, which was 0, so this entire term will become 0, so we don't need to add. And then we have the other side of the equation or the formula. So this AB is the combined particle, and this is the speed we have to find out, which is the speed after collision. And then since both particles coalesce, which just means that they become one, so it will have the mass of both A and B. So that will be 5 plus 2.5 kgs. So if we simplify this, we get this, and dividing 7.5 on both sides, we get that the velocity of the combined particle directly after collision is equals to 2 meters per second. On to part B. You have to find the loss of kinetic energy of the system due to the collision. The key words in this question is kinetic energy, system, and collision. The formula of finding a change in kinetic energy is always half times the mass multiplied by the final velocity squared minus initial velocity squared. However, this formula will not work in this part of the question. Movement is always equals to energy, or more importantly kinetic energy. So first we knew that A was moving towards B on a smooth table and B was not moving at all. So B was at rest, meaning B did not have any initial kinetic energy. However, A did have energy since it was moving, means that it would have had the energy of half times its mass, which was 2.5, and 6 squared, which was its initial speed. That means that the initial energy in the system was 45 joules. Then came the second part, in which A, B collided and they became one particle. And in the first part, we found out the speed directly after collision, which means that the particle moved after collision, so there will be energy. This will be half times the mass. And since it is a combined particle, it will be the masses of both A and B, so 5 plus 2.5, and then the speed directly after collision was 2, so this will be 2 squared. And if we calculate this becomes 15 joules. 45 joules is the initial kinetic energy, and this 15 joules is the final energy in the system. So we need to subtract those to find the loss. So 15 minus 45 is 30. So that means that the total loss of kinetic energy was equals to 15 minus 45, which is equals to 30 joules.